Hello everyone. This video is going to be about work and energy. In the first part of the video, I'm going to explain the basic concepts like the equations and formulas, etc. And in the second part, I'm going to go through the problem bank and explain each question. So first off, work. Work occurs when a force is being applied to an object and it causes displacement. And work is equal to force times distance with an implied cosine theta. More on this later. So if the box, or a force is being applied to the box of 10 newtons and displacement is 10 meters, then the work done will be 100 joules. The reason why there is a cosine theta is that the force must be in the same direction as the displacement. So, in the example I gave you, the force was going in the same direction as displacement, so we didn't need to worry about the cosine theta because the angle between them was 0, and cosine of 0 is 1. But if the forces are exactly perpendicular to each other, then you will find that no work is being done because cosine of 90 is 0, and therefore work will be 0. But what happens when the displacement and the force have an angle between them that is less than 90? Then only the x component of the force will be counted towards work, which will be this red line right here. If you remember from geometry, cosine theta is equal to the adjacent over hypotenuse. And in this case, the adjacent, which is the x component of f, is equal to the hypotenuse, which is the force, times cosine theta, which is where the cosine theta comes from. Let me box this equation really quick. You're going to use this quite a lot in this unit. And so, as you can tell from this problem, work is measured in joules. You can also find work from a force versus distance graph. If this is your displacement and this is your force, then the work will be the area under the curve. So, if the F value is 2 and the D value is 3, then the work done is going to be 6 joules. This problem right here, or problems like this one, is going to happen at least 2 to 3 times in the test, and so it's a good thing to know. Next we have power. Power is defined as the rate at which work is being done, and so you can probably guess that it is work over time, or force times distance cosine theta over time, and this is measured in watts. Next up we have energy. There are two types of energy: kinetic energy and potential energy. And one main thing to know about energy is that the kinetic energy and the potential energy must equal the total energy. So let's talk about kinetic energy first. The kinetic energy is energy that is currently being used, as opposed to potential energy, which is energy that could happen. A good way to explain this is, let's pretend that there is a person on a cliff. So right now, his kinetic energy is 0. And his potential energy is pretty high, let's say 10. So right here, he isn't moving, so there is no kinetic energy. But he has the potential to have a lot of energy and fall down to his death. So let's pretend that he dropped down and he is currently in motion and lost his feet apparently. So now he would say he would have a sizable amount of kinetic energy, like maybe 5, and a potential energy of 5, because he's still in the air, has potential to have a lot more energy. But now, what if he nears the floor, but doesn't actually touch it yet? Then when he is right here, before he touches the ground, then at this point, his kinetic energy will be the greatest, at almost 10, and he will have almost no potential energy. But when he touches the ground, he will no longer have any kinetic energy because he is no longer moving. I mean, unless of course he is, on the ground crying out of pain. But aside from that, he will have 0 kinetic energy, and is and that will be the end of our little guy. Sorry for the terrible analogy. So kinetic energy, as we mentioned before, is energy for when something is in movement. And so our equation for kinetic energy is mostly going to be 1/2 mv squared. And this is going to become useful when you start having to deal with work as opposed to energy. Because now the net work is equal to the change in kinetic energy, which is equal to 1/2 mv squared final minus 1/2 mv squared initial. And potential energy, for the purpose of first year physics, is mostly going to be mgh. Mass times gravity times height. And keep in mind that the kinetic energy and the potential energy must equal the total energy. That is going to be an important concept later on. And so that is going to be all for the basic concepts, and I'm going to move on to the problem bank now. Happy face.